Hi, Hola, Bonjour, and Salaam. Welcome to Blueprint Bazaar. In this session, we dive into the fascinating world of CAD modeling as we build a hopper using SolidWorks with a special focus on the sketch, loft, and shell commands. This project is an excellent exercise for both beginners and intermediate users who want to strengthen their foundation in 3D modeling while exploring tools that are widely used in real-world engineering applications. Our design journey begins with detailed sketching, the foundation of any robust model. In SolidWorks, sketches are more than simple outlines. They are fully defined, parametric instructions that drive the geometry of the 3D model. For this hopper, we create several profiles on different planes, a wider opening at the top to represent the input of bulk materials, and a narrower outlet at the bottom to simulate controlled discharge. These profiles are carefully dimensioned, aligned using construction lines, and fully constrained to ensure precision and adaptability throughout the model. Once the sketches are in place, we transition into one of SolidWorks' most powerful features, the Loft command. The Loft Boss base tool allows us to connect these varying cross-sections to generate a smooth, tapered body that captures the essence of a real industrial hopper. The top and bottom sketches are seamlessly blended into a single solid shape. Guide curves and center lines can also be added to refine the shape and control the flow between profiles, resulting in a clean and fluid transition. This step is crucial in industries where geometry affects the flow of materials, such as food processing, pharmaceuticals, plastics, and agriculture. After the solid body is formed, we introduce realism and manufacturing feasibility by applying the shell command. Shelling is a valuable feature in SolidWorks that allows us to hollow out the model while assigning a specific wall thickness. By removing a selected face, typically the top or bottom depending on the design, we convert the solid into a functional container that mimics how an actual hopper would look and operate. The shell command not only saves material, but also prepares the model for practical applications such as molding, sheet metal fabrication, or fluid and bulk material flow simulations. This combination of sketching, lofting, and shelling results in a well-structured, visually accurate, and mechanically sound hopper model. Each step is carefully designed to maintain parametric control and model stability. The process also enhances your ability to understand the relationship between sketches, features, and how design changes affect the entire part. This is an essential concept for engineers, aiming to create adaptive models that can be easily updated or repurposed for different applications. The final model is both visually sleek and mechanically functional, ideal for use in simulation studies, renders, or even direct export for manufacturing. More importantly, this project helps SolidWorks users practice precision sketching, effective use of advanced features like Loft, and the realistic application of wall thickness through shell. It demonstrates how professional-level components can be developed using a clear and methodical approach. Once the primary geometry is complete, additional features can be incorporated to increase both realism and functionality. Chamfers or fillets may be applied to the edges to eliminate sharp corners, improving safety and manufacturability. Draft angles can also be introduced to make the model mold-ready if you're designing for plastic production. With detailed features like mounting holes, flanges, or even a discharge gate, the hopper becomes more than just a visual representation. It turns into a fully functional digital prototype, ready for simulation, documentation, and downstream manufacturing processes. These enhancements not only add to the aesthetic quality of the model, but also align it with real-world engineering requirements. The versatility of this hopper model goes beyond just its shape. By applying appearances and materials in SolidWorks, you can simulate how the final product will look and behave under various conditions. Whether you assign stainless steel for corrosion resistance or polypropylene for lightweight plastic applications, these material properties offer insight into real-world functionality. You can even run simulations to test structural integrity or flow dynamics, making this simple model a gateway to exploring advanced analysis tools within SolidWorks. This enriches your understanding of how digital prototypes evolve into manufacturable components, bridging the gap between design and engineering execution. By the end of this tutorial, you'll have gained a deeper understanding of how to model complex tapered geometries, use guide curves for greater shape control, and apply thickness for manufacturability. This experience lays the groundwork for more advanced projects such as ducting, tanks, silos, and other industrial containers. Plus, it reinforces the core CAD modeling skills that will serve you across countless future designs. Thank you for being a part of this modeling journey with Blueprint Bazaar. We hope this session not only improves your SolidWorks skills, but also inspires you to explore more creative and technically demanding projects. Be sure to follow us for more CAD walkthroughs, mechanical design challenges, and industry-focused tutorials. Until next time, keep designing and keep innovating.